So we're looking at just how do we describe data, and you'll get to see it, the data in real context when you do your book problems today. So we're in section 11.1, and to describe data, there's a nice little acronym, I think you would say, called SOCS. So it goes like this. It's not spelled correctly, but it's like this: SOCS, S-O-C-S. So whenever you're looking at data, you want to describe, the characteristics are the shape, the outliers, which are those data points that are much greater or less than most other values. We just have an informal definition right now of outliers. I'll fill that in a second. And then we want to look at the center of the values. There's ways to measure center. And there's also ways to measure how spread out the data is. So a nice little acronym is SOCS: shape, outliers, center, spread. Those are the different possibilities for describing data. So let me describe, let me write what an outlier is. An outlier, it would be your value, would be a value much greater or less, and much greater or less than most other values. Than most other values. And there is a formal mathematical way of saying, is it really an outlier? But for now, we're just saying, does it look like an outlier when we look at the data? So that's for outliers. For center, so that's outliers. There are a couple of measures of center that you saw in your homework, and those are, you might have seen it as center, like measure of central tendency, measure of central tendency. So where's the middle? There's two main ways to measure that, and that's called the mean and the median. The mean is what we typically mean when we talk about the average. The average. The problem with the mean is that really large values like outliers can pull this average way higher or way lower. Whereas something like the median, which is, sometimes people say it's the average, but the median is less resistant to being pulled really high or really low. So that the median is the middle number, or average if there's an even number of numbers. So middle number or average of two middle numbers. And often the median is sometimes a more valuable number because it's resistant to being pulled higher or lower by those extreme values. So there's mean and median for center, and then for shape, the measure we have now for shape, you're going to get other ways to measure shape, but for now, the one that you've seen is mode. That's one way of describing a shape. There are others, and we'll get there. But the mode is most commonly occurring value, most commonly occurring. And you might have nothing that occurs more than once. If they're all unique, then you would say there's no mode, none. No mode. Makes you think of Edna Mode from that movie. Anyway, so there might be no mode. It might be unimodal if there's just one number that's most frequently occurring, or it could be bimodal. So you can have multiple modes, etc. So that's for shape. That's what we have for now. And then spread. How spread out is the data from the center? And so there's a couple of measurements we have for that right now. There's the range is a measure of spread, and that's just max minus min. Max minus min. And then what's our other measure of spread? The other thing you computed over the weekend? The standard deviation is a key measure. Standard deviation, and what it says is, on average, how far away are the values from the average. So it's basically, standard deviation is like the average distance from the average. Average distance from the average. And I'm gonna put the formula in here so we have everything, even though it was on the worksheet. I want it in your notes. So we use this sigma notation for standard deviation, equals the square root of, and you take, it makes sense by the definition. It should be easy to remember the formula. You take each value, you subtract it from the average, which is x bar, you square each one, and in the end you'll take the square root to kind of undo squaring it. But you want the distance away from the average, square it, plus dot dot dot, however many values you have, and x sub n minus x bar. So you take every value, you subtract it from the average, you square it, add them all up, and divide by n the total number of values. And it's the average distance from the average. So one example might be standard deviation for like age in here. Let's say the average was 15, and most of you were 16 or 14, then what would the standard deviation be? Well, the average distance from the average might be about 1. If most of you were greater or less than 1 year old from the average, the standard deviation might be 1. You'll do some more examples in the book problems today.